Okay, in this video I want to talk about constructors. Now, a constructor is a special member function that is used to initialize objects, and this allows you to initialize the member variables or the state of the object. When we declare a regular variable such as an integer or a float, we can just initialize those to the respective values, right? But an object is more complex because it can have multiple member variables. Then in the lesson on structs, I showed you that you can initialize a struct using list notation, so similar to how you would initialize an array. And when it comes to classes, we typically use constructors instead, and you can actually use constructors with a struct as well. So this is all about initialization, how to initialize an object. And going forward, especially once we get to inheritance, the initialization of our objects are more complex, so these constructors really help us with that. A constructor is not invoked in the same way that you are familiar with other member functions. Instead, it is basically called or invoked automatically when an object is created or constructed, right? A few more notes on constructors. A constructor doesn't return anything. As I mentioned, it is used primarily for object initialization, so don't specify a return type for a constructor. Another interesting thing is, the constructor must have the same name as the class. You can see that in the example to the right. Now, since it is similar to a function, it can also be overloaded, and of course we want to specify this in the public section, so following the public member access modifier. Again, you can see an example to the right here. I have a class called GameStats. Under the public member access modifier, I have the constructor. It's called GameStats. The name of the constructor matches that of the class name. Now, I am declaring and defining the constructor in the body of the class definition, but of course you can separate that out, similar to the member functions that we've discussed previously, and I'll show you that here in just a second. But just to keep it concise, I define it in the body of the class definition. As with member functions, your constructors have access to your member variables. So in the example, you can see I set current level to 1 in this constructor. If you remember from previous examples, I would do int current level, and then I would set that to 1 to give that current level variable a default initialization, otherwise we'll get garbage, right? So we are basically doing the same thing here, but we are using a constructor instead. So as soon as you push that object onto the stack or onto the heap, that constructor is called, and it sets current level to 1. Okay, let's look at a quick example of this in Visual Studio. Okay, I have this example again. So I have class GameStats. I have these two functions, getCurrentLevel and setCurrentLevel. And then in the private section, I have a member variable, currentLevel, which I set to 1. Okay, let's go and create a constructor. Now remember, this doesn't return anything. And for right now, I'll go and define it right here in the body of the GameStats class. So what are we gonna do? Well, here we have this default initialization of current level. I'll go and change that. I'll remove that, and I'll go and set that in the GameStats instead. And that's all I'm going to do for now. So GameStats again, this is the constructor, and you can see the name is the same as the class name. We have opening and closing parentheses in this. I'll talk more about the different constructors that you get. So you have a default constructor, which this is right now. And then you can overload it so you can specify parameters. Okay, so we'll talk about that in an upcoming subsection. Okay, so here I simply go and define those two member functions, getCurrentLevel and setCurrentLevel, and then I have main. Here I go and declare the object again. Game is an instance of GameStats. I do console output game.getCurrentLevel. Alright, I'll build and run that. And that prints out 1. Of course, in getCurrentLevel, we return the current level. Okay, I want to talk about the default constructor in a bit more detail, which is actually what we've been using so far, more specifically, a user-defined default constructor. No arguments are specified when calling the default constructor. It's also referred to as the no-args constructor. The next point is quite important. If you do not define any constructors for the class, then the compiler will generate a default constructor that does nothing basically. So this means if you provide a user-defined default constructor or a constructor that does have formal parameters, whether one or more formal parameters, then that means the compiler will not generate a default constructor. So again, it's only in the case where you do not provide a constructor that the compiler will generate a default constructor. So when is this default constructor invoked? Well, when a new object is created on the stack or on the heap. So in the first statement, I create an object called player1, which is an instance of the class playerStats. Now notice here that I'm not using parentheses, not even empty parentheses. I'm just specifying the name that I want for the object, and then what that object is an instance of. so in this case player stats. And when that statement evaluates, a new object will be created on the stack, and then the state of that object will be initialized to what we specify in the constructor. So in this example, let's imagine we do not have a user-defined default constructor. So it's going to generate a default constructor that does nothing. Then we have this object player1 now, and the same thing in the next statement where we have player2, which is a pointer to an object of type playerStats on the heap. Now if you think for a moment what the state will be of each of those objects, well, the member variables will not be initialized unless you actually use member initialization, so you set each member to some value that it will get by default. But again, when it comes to classes, you typically want to do that using a constructor instead. So if you don't do that, then of course those member variables, let's say they are integers or floats or something, those will now contain garbage, right, if they are not initialized. So that's why it's important to always initialize, and not just variables, but also your objects and the state of your object, so that the member variables of your objects will not contain garbage. Or in other words, if you remember from the first module, garbage again means that those variables will contain just some random value, and that makes it difficult to debug those variables. And the same applies to member variables, or the state of an object. So you want to define and initialize your objects before you use them. That's important, just like you do with regular variables. And that is really the point with constructors. And that brings me to user-defined default constructors. Now, it's best practice that you should define a default constructor for each class that you define, and you do that by considering the default state that is desired when you instantiate a class and you don't provide arguments for the initialization. So here's a quick example, as we had it before, basically, minus one or two member functions. So in the public section, I have the default constructor. Again, the name matches that of the class name, so it's GameStats parentheses. And in this case, it's also defined in the body of the GameStats class. So when this constructor is invoked, in other words, when an instance of this class is created, then I set current level to 1. So this is what will happen by default. This is now a user-defined default constructor. And this means I know what the state is going to be for each time I instantiate that a particular class. Of course, you can overload that constructor, and we'll talk about that as well. And it's important to note that with this example, the class will have no default constructor. You can see in the public section that I have a one argument constructor. In other words, it has one formal parameter and it accepts one argument. In the body, I set current level to x instead of 1. It would be better to have a default constructor that accepts no arguments along with this one, because this class will have no default constructor, right? So if you try and instantiate a class and you don't specify an argument, you'll get an error. Again, if you want to do this, if you want to specify parameters, so formal parameters, because you want your constructor to accept arguments, then make sure you also include a default constructor. Okay, so before we move on, I'd like to go and separate the definition and the declaration out. Copy that, and then I'll just go and delete that out. So I have the constructor declaration right here. I'll scroll down right after the class body. I'll paste that in. Now remember that a constructor does not return anything, so we simply have to specify what it belongs to. Okay, this GameStats constructor here, what does it belong to? It belongs to the GameStats class, and we do that using the scope resolution operator. Once I have it set up like this, and the same thing with other member functions, here's this body here. It's almost like we are still in the same scope, so within the body of this class definition. And that is why we can access the member variables, so I can access current level right here. I don't have to do scope resolution or anything like that. I can access the members directly without having to do any other tricks other than doing that scope resolution. Now going forward with inheritance, it gets a bit more complicated than this, but maybe that's an easy way of understanding why we still have access to the members, because of course you have access to local members within the same scope, so within the same code block. Okay, so I have separated out the declaration and the definition of the constructor now. And this is the same program. I instantiate GameStats. I create an object called game, and I simply do cout game.getCurrentLevel again. Okay, we'll get 1. Now, just out of interest, let's go and do a member initialization. So I set current level to 15 by default. And now remember, in the constructor, when the constructor is called, we set it to 1. So think for a moment what you think will get printed out to the screen. And I'll build and run, and we should get 1. Yes, as you can see, that prints out 1. So whatever you specify in your constructor will override whatever you initialize your members to using this member initialization, right? So remove that. Again, we prefer to use constructors to initialize the state of our objects. Now let's do something else. Let's say we try and return something, build and run, and of course you'll get an error. Constructor cannot return a value. Okay, let's do something else. I'll cut that out and paste it down here in the private section. And you can already see we have an error. Instantiate a new object uses the default constructor. It is inaccessible. Build and run and you'll see we get an error like that. Cannot access private member declared in class GameStats. And that is why you declare your constructors in the public section, so that it is accessible. Now of course you're not going to do dot and then the constructor as you would do with other member functions, even though it's similar to a member function. Again, we don't use it in that way, but at the same time you still need to have it in the public section, otherwise you cannot invoke that constructor from outside. Okay, next what I'll do is I'll specify a formal parameter and I'll just call it x. So current level is equal to x. And this is how we will invoke that now. So you use the parentheses and then you specify the argument. Build and run and that prints out 5. Okay, but so here is the problem. If I go and remove the argument and the parentheses, you will see that we get these red squigglies and it says no default constructor exists for class GameStats. Just build and run that to make sure. GameStats, no appropriate default constructor available. Again, no appropriate default constructor available. I'll just scroll up and that's because we have this constructor that accepts an argument. So we do not have a default constructor because a default constructor does not accept any arguments, right? Okay, but if I go and comment that out and maybe comment that line out as well, what's going to happen now is I'll just scroll down. This will now use a default constructor which will be generated by the compiler, and that constructor is going to do nothing. So if I build a run now, you can think what's going to happen. We'll get some crazy number because the member variables now contain garbage. They are not initialized. Previously I set current level to 1 using member initialization, but in this case I did not. So when you go and instantiate this class, the state of those objects can be anything, and thus the member variables will contain garbage. And that again is why we use constructors, and why I always want to specify a default constructor, even if you set the member variables to 0. At least that will make debugging easier, right? I'll just go and uncomment that. So how can we fix this? Well, we go and overload that constructor. So I have a default one now, and I'll actually just copy that one over. So this here is now the default constructor. Why? Because it doesn't have any formal parameters, so it doesn't accept any arguments. And we overload that constructor, so this one right here accepts a single argument, so it has a single formal parameter. And of course you can go and overload this constructor so that you have one that accepts multiple arguments, right, that have multiple formal parameters. But for right now we'll leave it like this. So we have the default one, and that is the one that will be called in this case right here. Build and run, and we'll get 1. And 7. So use parentheses and I pass it 7 as an argument, and of course that is going to use our overloaded constructor. Set current level equal to x, which will be 7. Now here is another thing that I want to show you before we move on to the next section here, is don't do this. Remove that and all of a sudden expression must have a class type. If you build and run, then again you'll get this error. Left of dot get current level must have a class, struct, or union. Okay, so it doesn't recognize game as an object, and you might think why that is. If you look at this a bit more closely, you'll notice that this is actually a function declaration. So I have the return type right here, GameStats. The name of the function will be game. we have no formal parameters, and we end that off with a semicolon. So this, if you look closely again, is a function declaration. So at first the syntax might seem a bit similar and a bit confusing, but if you want to use the default constructor, don't specify empty parentheses, right? You want to remove those. As we have done it up until this point, that now creates an object, and that object is of type GameStats, or is an instance of GameStats. So that'll work fine. And then in the case where you have constructors overloaded, where it has a parameter or multiple parameters, so in other words it accepts an argument or multiple arguments, then you can use the parentheses and then specify your arguments. So it's a slight syntactical thing that you have to get used to, but if you think about it for a second, again it makes sense. Again, this right here, right, if you think about it for a second, that is a function declaration. And here we are instantiating GameStats, we are creating an object within name of game. And of course, just for fun, we can create another one now. And I'll use our overloaded constructor and pass in an argument of 5. To console output game2.getCurrentLevel. As expected, the first line will print out 1, the second line will print out 5. So I'm spending quite some time on this. I'm just trying to get these basics down for you, because some of the syntax can seem a bit complicated if you are new to programming. But as usual, I'm just trying to show you that if you take it step by step and actually look at what you have, that it's quite logical and it's not that difficult to follow, right? You just have to spend some time and look at what it is that you have.